Hello, my name is Chris from UC Merced's Math Center. Today I'll be going over geometric series. Geometric series. So a geometric series can take the form of summation of a sub I, where I equals to 1 to n, and from here we can find the partial sum. Which is generally written as S sub n, where n is your number of terms, and that's equal to a multiplied to 1 minus r to the n over 1 minus r, where a is equal to your first term in your series, so a sub 1, and r is the ratio between each term, so between in the special case where the absolute value of r is less than 1, then you can actually find the sum of an infinite series. So the summation from 1 to infinity of a sub I is equal to a over 1 minus r. But this is only when the absolute value of r is less than 1. Another thing to note is that often geometric sequences take the form summation n equal to 1 to infinity of a times r to the n minus 1. And this is especially useful when you're giving a set of terms and you're trying to find the summation form. So let's work through a few examples. So example 1, we want to evaluate this series. So n equal to 1 to 20, 3 times negative 2 to n. So we have the series from 1 to 20 of 3 times negative 2 to the n. So we need to identify what our a and r values are to be able to do this. So why don't we first write out the first 3 terms to figure out what's going on. So a sub 1 is equal to 3 negative 2 to the 1. Negative 2 to the first power is just negative 2. Negative 2 times 3, negative 6. A sub 2 is equal to 3 times negative 2 to the second. Negative 2 to the second, 2 times 2 is 4. 4 times 3, positive 12. And now a sub 3 is 3 times negative 2 to the 3. 2 cubed is 8. We still have this negative sign since the power is odd. 3 times 8 is 24, so negative 24. Earlier, we said that a is equal to a sub 1, so our a is negative 6. And then each of these terms is increasing by negative 2, by the ratio of negative 2. Because negative 2 times negative 6 is 12, negative 2 times 12 is negative 24. So now we can find the partial sum, s sub n, which we wrote here as a 1 minus r to the n over 1 minus r. And we are trying to find the 20th partial sum. So s sub 20 is equal to negative 6, 1 minus negative 2 to the 20th, divided by 1 minus negative 2. And so we calculate this. Negative 6, negative 2 to the 20th. Since it's to an even power, we know that this number is going to be positive. So 1 minus 10, 48, 57, 6. Divided by 1 minus negative 2 would just be 3. And then this just works out to be 20, 97, 150. So a very large number. So, and that's how you would find a partial sum. Now we'll move on to example 2. We want to find the series given a partial sum. So find the series a sub n if s sub 4 is equal to 26 over 27 and r is equal to a third. So what this is saying is that when we take the first 4 terms of our series, add them together, we get 26 over 27. And the ratio between each term would be 1/3. So we can write this as s sub 4 is equal to a 1 minus r to the 4 over 1 minus r. We know what s sub 4 is. We know what r is. We need to find a so that we can write the series. So this is 26 over 27 equal to a 1 minus a third to the 4th over 1 minus a third. So from here, we can say a 1 minus a third to the 4th. That's the same as 1 to the 4 over 3 to the 4. 1 to the 4 is 1. 3 to the 4th is 81. 1 minus a third. One minus 1 over 81, that leaves you with 80 over 81 times. Now 1 minus a third is 2/3. We're dividing by that, so we take the reciprocal. So we multiply it by 3/2. From this, we move on. 26 over 27 is equal to a times 240 over 162. Right? 80 times 3, 240. 81 times 2 is 162. This simplifies down to be 26 over 27 is equal to a times 40 over 27. So now we need to multiply by 40. We need to multiply by 20 over 40 to cancel out this term and multiply it to the other side. So 27 over 40 times 26 over 27 is equal to a. 27, these two 27s would simplify out. You're left with a is equal to 13 over 20. So now we have all the information we need to write it in summation form over here. So we can write summation n equal to 1. And since we found it up to the fourth term, why don't we just write to 4? A we found was 13 over 20. And then we want to multiply it by r, which we were told is 1/3 to the n minus 1. And we already know that this is equal to 26 over 27. And now we can go ahead and do one last example. So, example 3. Okay, so we want to find the series given these terms. 4, 2, 1, 0.5, 0.25. So we need an A and we need an R. Well, we know that A is equal to A sub 1. A sub 1 is your first term. In this case, it's 4. And then R is the ratio between each term, or A sub 2 over A sub 1. A sub 2 is 2 divided by 4 is equal to 1/2. And we can make sure that it's a geometric sequence and that each term has the same ratio between it. So let's go ahead and also check A sub 3 over A sub 4. Oops, A sub 4 over A sub 3. Sorry, I misspoke. So that would be 0.5 divided by 1, which is also equivalent to 1/2. So now we can just go ahead and put that in summation notation. We can look over here. It's the summation. N is equal to 1 to infinity. A we found to be 4 times R, which we found to be 1/2, to the n minus 1. And so I hope that was very helpful to you guys. See you guys in the center.